Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we calculate the gradient of a straight line. But before we start, if you're new to my channel, make sure you press the subscribe button and hit the notification bell so that you don't miss out on any new videos. So to start off, what do we mean by the gradient of a straight line? Right? Gradient of a straight line is simply a measure of how steep it is. And to calculate the gradient of a straight line, we simply say the change in y over the change in x. Right? So I shall use the letter m to represent the gradient. Right? Let's say m, or let me write gradient here. Gradient is given by the change in y over the change in y coordinates over the change in x coordinates. So basically we need two points to calculate the gradient of a straight line. Right. So let's say the first point A. So the first point A is x not 1, y not 1. Then the second point B is x not 2, y not 2. So we're saying that the gradient would be change in y coordinates. We're saying y2 minus y1 over the change in x coordinates. We're saying x2 minus x1, or even vice versa. Right, it used to work. So we can even say y1 minus y2 over x1 minus x2. But what we basically want is to get the change in the x and y coordinates. So this is the formula of how we calculate the gradient of a straight line. And I'm going to demonstrate using these two examples. So for this first example, we've got the 2 points. Point A is 1, 2. Then point B is 6, 5. Right. So coming up with a quick sketch of the line, we're saying that this is the xy plane, 0 there. So this point being 1, 2, let's say 1 is there, and then you've got 2. So this is A, and then point B is 6, 5. So let's say 6 and then 5. So this is our point B. Okay. So we've got this line, right, joining these 2 points. Right, so we want to calculate the gradient of this line, which we are saying this is given by the change in y over the change in x. Right, so we shall say that gradient m for line AB would be equal to y2 minus y1, we're saying 5 minus 2, over x2 minus x1, we're saying 6 minus 1. So this will give us 3 over 5. It's the gradient. And as you can see, this is a positive gradient. We're saying the change in x over the change in y. Now for example number 2, what we want to do is that we want to find the gradient for these points. Let's call those points C is 0.15. And then D is 0.52, right? So as well, coming up with a quick sketch of the line joining those 2 points, we're saying we've got xy plane like that, 0, 1, 5, let's say 1, then 5B. So this is point C. Then point D is 5, 2. So 5, 2. This is point D. So this is the line joining the point C and D. So calculating the gradient for line CD, and here I'm just using the letter M to represent the gradient. So gradient for line CD, we are saying change in y 2 minus 5 over the change in x 5 minus 1. Right? This will give us minus 3 over 4. So now what do we see? The difference between these two answers is that this one is definitely positive and this one is negative. So what does this imply? This implies that for lines that slope slope upwards, right? As you can see, right, this line is sloping upwards, right? We've got a positive gradient. Upwards to the right, we've got a positive gradient. And then this line is sloping downwards to the right as well. So this will give us a negative gradient, right? So now let's attempt these questions real quick. Number 1 up to number 3, right? Which require us to find the gradient and of course just do a bit of application. So allow me to erase this part. Okay, so now let's start off. So number 1a, we want to find the gradient for the line joining these 2 points. So for number 1a, we said change in y over change in x. So gradient m is going to be minus 1 minus 1. So that's minus 1 minus 1 over 0 minus, then minus half that's already there. So here we'll get minus 2 over half, right? Which would be equal to minus 2 times 2 over 1 to give us a minus 4. So for part A, the gradient is minus 4. Then for part B, the gradient m, given by the change in y over change in x, we're saying 0 minus 10, change in y, over change in x, 0 minus 7. So 0 minus 7, right? We're saying 0 minus 10, we get a minus 10. Over minus, we get a plus 7. So minus 10 over 7 will be the gradient for part B. Now for part C, gradient m is going to be given as well by the change in y over the change in x, like we mentioned. So we are saying 6 minus 5 for the change in y, over 1 minus 7 for the change in x. 1 minus 7. So 6 minus 5, we get a 1. Over 1 minus 7, that's a minus 6. So we get minus 1 over 6 is the gradient for part C. Now moving on to number 2. Number 2 says, find the value of A if the line joining the points 3a, 4 and a minus 3 is a gradient of 1. Right. So, okay, let me just work it out here. So for number 2, we are told that already the gradient of the line joining these 2 points is 1. So now our job is to come up with an equation for the gradient, right? For which we say the gradient m is given by the change in y over the change in x. So the gradient for the line joining these 2 points, we're saying the change in y shall be 4 minus 3. So 4 minus 3 over the change in x. Change in x is 3a minus a. So 3a minus a. And this should be equal to a gradient of y. Right, like it says there. Then now we shall proceed, right, to have 4 minus 3, that's 4 plus 3, to give us a 7, over 3a minus 2a, sorry, 3a minus a, that's 2a. So this is equal to 1, and then this implies that 2a is equal to 7. Dividing both sides by 2, a would be equal to 7 over 2, which you can write as 3.5 as well. So this was for number 2. Now for number 3, allow me to erase this part. All right, just create some space here. Okay, and this as well. Okay, so for number 3a says find the length of the line segment drawn from P, which is 2,1, to Q, which is 6,4. So now this is a bit of application, right? So first of all, what we need to do, we need to come up with a sketch of the line segment that they're talking about here. So we're saying P, this is now number 3a. So we're saying P is 2,1, and then Q, point Q is 6,4. Right, so to come up with the quick sketch, this is the y, that is the x. So 2, 1, we're saying 2 is here, and then this 0. Then you've got 1, so this is our point P. And then point Q is 6, 4. So we'll say 6 there, and then 4 there. So this is point Q. So this is the line segment they're talking. But now, how do we find the length of this line segment? Now we shall say that, what is the change in x? X is changing from 2 to 6. So this distance, which is the change in x, is 4, right? So this distance is 4. And then the change in y is this distance, right? And as we can see, y is changing from 1 to 4. So this distance is 3. So now, what do we know? Here we've just formulated a right angle triangle. You know that's a 90 degrees, right? And then now, what do we know? We've got a 3, we've got a 4, and we need to find the length of PQ. We can apply the Pythagoras Theory. So applying the Pythagoras Theorem here, we are saying PQ squared shall be equal to 4 squared plus 3 squared, which implies that PQ is equal to the square root of 16 plus 9, which is the same as root of 25, which will be equal to 5. So 5 units is the length of this line segment drawn from P to Q. And that's how we calculate that. Now moving on to part B. Part B says, find the coordinates of the midpoint of the line segment PQ. So now we want to find the midpoint of this line segment PQ. And what we do is that we add for PQ, we add the x coordinates, then divide by 2, right? And then we also add the y coordinates, then divide by 2. So we say that the midpoint, this part B, so we say the midpoint of PQ is given by, let's say this is x not 1, y not 1, and this is x not 2, y not 2, right? So we say that the midpoint of PQ is given by x not 1 plus x not 2 over 2 for the x coordinate. Then for the y coordinate, y not 1 plus y not 2 over 2. So this would be the midpoint. So now just substituting, we're saying 2 plus 6. 2 plus 6 for the x coordinates divided by 2. And then for the y coordinate, that's 1 plus 4. 1 plus 4 divided by 2. So here we get 8 divided by 2, that's 4. And then 5 divided by 2, that's 5 over 2. So 5 over 2 is the midpoint of the line segment PQ. Okay, so this was simply on how we would calculate the gradient of a straight line. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.